Hi everybody, today we are going to do some coordinate geometry with rectangles. So first we're going to do a little bit of coordinate geometry review. So there are two formulas that we're going to be using today and that are really important for us to remember. The first is the slope formula. So you can find the slope between 2 points using the formula y2 minus y1 over x2 minus x1. Now, a few important interpretations of the slope. If your slopes are equal, that means that your two lines are going to be parallel. So if you end up with the slopes a over b and a over b, if the slopes are the same, the lines are parallel. The other way you can interpret slope is if you have slopes that are opposite reciprocals. So opposite meaning one is positive and one is negative, and reciprocals meaning the numerator and denominator are switched. So you can see here a is in the numerator, b is in the denominator. For the reciprocal, b is now in the numerator and a is in the denominator. So both of these things need to be true. And if both of those things are true, the two lines are perpendicular, which remember means that they make a 90-degree angle. So that's how we're going to be using our slope formula today to determine if lines are parallel or perpendicular. And then we're also going to be using the distance formula, so how to find the distance between 2 points. And that formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, so let's give all these a try. So first, we are given 4 coordinates, A, B, C, and D. And first they would like us to find the slopes of lines AB and lines CD. So A is -3, 5, B is 1, 3, and then C is 1, 1, and D is 2, 3. So first let's find the slope of line segment AB. Remember, M is the variable that we use to represent slope. So let's use our formula, but before we do that, let's label our coordinates. So our formula is y2 minus y1 over x2 minus x1. Remember, when we subtract a negative, it becomes a positive. So now all we have to do is simplify. 3 minus 5 is -2. 1 plus 3 is 4. So our slope is -1/2 when you simplify that fraction. Now let's find the slope of line segment CD. So same idea, let's label our coordinates. And let's use our slope formula. So y2 minus y1 over x2 minus x1 equals 2 over 1. So those are our slopes. Now part B asks us to interpret our slopes. So first thing we're going to check for is, are the lines parallel? Well, since the slopes are not the same, we can conclude that our lines are not parallel. Let's check for perpendicular. So there's two things we need to check for. Opposites, so this slope is negative, this slope is positive, so they are opposites. We also have to check for reciprocals. You might notice that here 1 and 2 have been flipped. So these slopes are both opposite and reciprocals. So we can conclude that AB is perpendicular to CD. However, I want you to make sure that you add a mathematical justification. So let's say because the slopes are opposite reciprocals. Okay, now they would like us to find the distance of line segment AB and then CD. So they want us to find the distance between those points. So let's find the distance of or between points A and B. So we're going to use our formula, x2 minus x1 squared, so 1 plus 3, plus y2 minus y1 squared. So now we just have to simplify it, and we take the square root of that. So 4 squared plus 2 squared. 4 squared is 16. 2 squared is 4, so that gives us the square root of 20, which of course we are going to need to simplify. So I'm going to factor out our numbers. And you'll see that the distance from point A to point B is just 2 root 5. Now let's do the same thing for line segment CD. Let's find the length of that line segment. So the distance between point C and D is the square root of x2 minus x1 squared plus y2 minus y1 squared. So let's simplify. We have 1 squared plus 2 squared. 1 squared is 1, 2 squared is 4. So the distance from point D to point C is square root of 5. There you have it. All right, let's see if you can pause the video and give this problem a try. Okay, so first let's check your slopes. If you find the slope of AB, you should end up with a slope of positive 1. Find the slope of CD, you should also find a slope of positive 1. So if you compare the slopes, you'll notice that they are equal. Therefore, you can conclude that AB is parallel to CD. Now let's check our distance formula. So here's the distance from point A to point B, 3 root 2. Here's the distance from point C to point D. And what we can conclude from here is actually that line segment AB is congruent to line segment CD. They have the same length, so they are congruent. All right, so now we're going to use what we just practiced to help us do a little bit of coordinate geometry. So here they give us 4 coordinates of a quadrilateral, and they ask us to determine if that quadrilateral is a rectangle. So let's start by plotting our points and see what's going on here. So we have -4, -1, -2, -5, 4, -2, and 2, 2. So this was F, this was G, this is H, and this is J. So to prove that something is a rectangle, there's a few different ways we can go about this. One important fact about a rectangle is that all 4 angles are 90-degree angles. So let's see if we can check for 90-degree angles. That's our goal. So if we are going to check for 90-degree angles, we know that these lines should be perpendicular. Luckily, we know how to determine if the lines are perpendicular by comparing the slopes. So we are going to want to find the slopes of all 4 of those line segments. So let's start with the slope of FG. So we're finding F to G. So we can do y2 minus y1 over x2 minus x1. And if we simplify that, we get -4 over -2. Positive 2, which is a slope of -2. So now let's find the slope of GH, so G and H. So we can do y2 minus y1, so plus 5, over x2 minus x1, so plus 2. And here we get 3 over 6, which is 1 over 2. Okay, now let's find the slope of this line, HJ. So y2 minus y1 over x2, 2 minus x1. So this equals positive 4 over -2, which is -2. So now the last one we need to find is the slope of line segment FJ. Okay, so we have point F and point J. So we can do y2 minus y1 over x2 minus x1. So here we have positive 3 over positive 6, which is 1 over 2. So we can conclude a lot from our slopes. So the first thing that you might notice is that we have some slopes that are equal. We see that the slope of line segment FG is equal to the slope of line segment HJ. That means that we can conclude that FG is parallel to HJ, and that's because they have the same slope. Okay, let's go ahead and add that into our figure. So FG is here and HJ is here. And we also notice that the slope of GH is equal to the slope of FJ. So we can conclude there that GH is parallel to FJ. So from here, we can add that to our figure like this. So remember, this shows that it could be a parallelogram, but to be a rectangle, we also have to show that these are all 90-degree angles. So once again, our justification for that was same slope. So now let's see if we notice if any of those lines are perpendicular. So if you look at these two slopes, you might notice that they are opposite reciprocals. Negative, positive, 2 over 1, 1 over 2. So from these two slopes, we can conclude that FG is perpendicular to GH. Oh, well, that means that this is a 90-degree angle. From these two slopes, we see that they are opposite reciprocals as well. So we can conclude that GH is perpendicular to HJ, and we can add in our 90-degree angle there. We can also see that these two are opposite reciprocals, so we can conclude that HJ is perpendicular to FJ. And of course, we can see that these two are also opposite reciprocals. So from that, we can conclude that FJ is perpendicular to FG. So we have shown that all 4 of those angles are right angles. So since we know that the opposite sides are congruent, and we also know that all 4 angles are 90 degrees, we have effectively showed that FGHJ is a rectangle. All right, so I'm going to ask you now to pause the video and see if you can give this problem a try. All right, so let's check our work. So here you can see I plotted the points J, K, L, M, and I went through the process of finding the slope of each line segment. So right off the bat, you might notice that none of them are the same. So that means that JM is not parallel to KL, and JK is not parallel to ML. You'll also notice that while these two are perpendicular, these two are not. So this is not even a parallelogram, so it is definitely not a rectangle. However, you do have to show how you know that. So here I concluded that the opposite sides are not parallel. So we know that JKLM is not a rectangle. All right, that is all for today's lesson. Thank you so much for watching.